Hello everybody, today I am presenting the work that has been done with the Mexican Transversity Group at Instituto de Física, Universidad Nacional Autónoma de México, a constraint fit of the valence transversity distribution from the hadron production. This research was made by Jorge Benel, who is talking, Dr. Aurora Courtois, and Dr. Rodolfo Ferro Hernández. Well, let's talk a little bit about the background first. First of all, what is a transversity distribution? It's one of the three leading twist parton distribution functions, or PDFs. These PDFs explain how quarks and gluons behave inside the proton at different energy and Bjorken values. The Bjorken value is this X up here, and because of its nature, the transversity distribution cannot be seen in the most common deep inelastic scattering, or DIS, experiments. So it is the least known PDF. Our data was extracted using a collinear framework, combining data from Hermes and Compass experiments on polarized semi-inclusive DIS, together with data from Bell experiment on positron-electron annihilations. And theoretically, this PDF has some first principle constraints that let us know how it should behave, where the most important is the positivity bound known as the Soffer bound, or SB. So let's go to the question. Usual extractions rely explicitly on the fulfillment of the Soffer bound. In simple words, these transversity distribution fits cannot be outside the Soffer bound. However, there is a disagreement between the data and the Soffer bound in some regions, not because the theory is wrong, but because the current Soffer bound limit comes from experimental data. Because of this, we asked ourselves, can we find a way to fit the transversity distribution without relying on the Soffer bound explicitly? Spoiler alert, yes, we could. So how we did it? First, we did a reweighting of the transversity data, using a Bayesian approach and taking into account the Soffer bound implicitly. After that, we assured the fulfillment of other theoretical constraints with two sequential fits using Lagrange multipliers method. And finally, we repeated this step 200 times using a bootstrap technique. Here, we have the results of the transversities of the up and down valence quarks at 68% in yellow and 95% in blue, with the Soffer bound in white. The first result that we could see is that it fulfills the expected small x behavior as the theory states. The up distribution fully realizes the Soffer bound. This is, everything is inside the positivity bound, inside the Soffer bound. On the other side, the edges of the down envelope reflect the relaxation of the bound combined with the lack of data in the large X region. Wider error bands outside the data range with respect to the error band inside that range found in previous extractions. This is allowed by the absence of data in this region up here. So what we did conclude? Well, this fit, despite not depending explicitly on the theoretical constraints of the Soffer bound, shows results that agree with what was obtained in the previous adjustments and adds flexibility to the fit and a more realistic error. Furthermore, it allows the same analysis to be carried out at different energy values. Thus, an extension of this work would be the inclusion of a DJ lab routine to be able to obtain these results. And last but not least, I'm glad that I can present this research published this year at the 60th anniversary of my sciences department. Personally, it wouldn't have been possible without the fundings of the Beca Alianza del Pacífico and Unidad de Investigación de la Facultad de Ciencias, Universidad Nacional de Ingeniería. Thank you very much for your attention. I would love to solve any of your questions.